Hello everyone, this is another student's quest. This question came from Faridabad and the sender name is Gotavya. The question simply says that if the real numbers A and B are such that there is a set provided A, which is the elements, the A is composed by these elements 1 by root over square A square plus B square, and this A and B are coming out from this polynomial equation x to the power 4 8x cubed plus 24 bx squared plus 32ax plus 16 is equal to 0, and this polynomial holds for at least one x belongs to real number, one real x. Then we have to find out the maximum value of A. So all that we have to find out the maximum value of this. The A means the maximum value of this quantity. So maximum value of the quantity square root of A squared plus B squared. It corresponds to the minimum value of the reciprocal of it. So that is minimum value of a square root of A square plus B square. So our main goal is to find out this thing. So this is our goal. Goal is this. We have to identify the minimum value of this. So before you jump to the solution, I request you to give an attempt. So let's see the solution, how we can solve. You notice there is this thing is given there, the polynomial. This polynomial is a very special kind of feature we can observe. Let's see. So let me write this polynomial. 8ax cubed plus 24bx squared plus 32x plus 16 is equal to 0. You notice that when I substitute x equals to 0 there is no satisfaction of this equation we have. It simply means that we can divide by x square. And why I'm dividing, you come to know very soon. You notice this thing, if I divide, this will become x square. And I'm writing by okay, so let me divide first. So 8ax plus 24b plus 32a into 1 by x and plus 16 by x square. So what we can do now, that I am taking x square and 16 by x square together and see the consequence. So this will give us x squared plus 16 by x squared, and from these two terms, the 8ax and 32a 1 by x, I'm taking the 8a common. So 8a common, so this will give us x plus 4 by x, and this 24b I am just keeping alone. So this way you realize that there's something happening over this quantity and this quantity. I can write this first term as x plus 4 by x the whole square minus 2ab, so that is 8. And there I have 8a and then again x plus 4 by x and plus 24b is equal to 0. Now what we can observe here, that I can assume this x plus 4 by x as a new variable, let's say it's t. But there is a one catch here, that the x can be any positive number, so t will have the minimum value as 4. Why? Because suppose for x positive, I can apply the am greater than gm property. So this is am, I'm writing by 2, so I'm sending this 2 there, and this will give you x into 4 by x. So of course the t value is greater than 4 when x is greater than 0. When x is lesser than 0, that should be lesser than minus 4. So I can collectively say that this condition is there, but with this thing, the mod t is greater than equal to 4. So this thing I have to keep in mind whenever I'm dealing with the quadratic I want to make. So here I got the quadratic t squared minus 8 plus 8a t plus 24b is equal to 0. Now real fun starts from here. Up to here maybe many students have cracked also. So what we can think from here, that's important. So let's try to understand what is the intention of this minimum of root over a square plus b square. So what I'm going to do here and try to convince, I want to say. So okay. So think this value, when we say that this value, if you want to look at it, is the distance of the point a comma b from the origin. And we want to find that distance, we have to minimize. So minimize that distance. That's the main thing they're asking. So what we interpret from here, that it is like, suppose I have a straight line in the plane of AB. So let's say A and B is there, and this A, B is the variable point in this plane, and it is lying on that line. And we want to find the distance of the A comma B from the origin, and that distance should be minimum. It means our intention is to find or locate that point on this line, which is in the form of A comma B, should be minimum. It means that distance is nothing but the perpendicular distance of this line from the origin. So if you find this distance formula, means length of perpendicular from the origin, that is sufficient to tell that we found the minimum value of root over a square plus b square, because a and b are actually roaming on that line, and suddenly we got that point, and that point is also a comma b. So we located that a comma b from the origin, which is at the minimum distance from the origin, that we located that point on the line, and we found the distance from the origin, which is actually at the minimum distance from the origin, and that we found actually. So can we think this equation what we have in hand as the straight line in terms of a and b? Of course we can. We can think is like, this is the coefficient 8t is with a, and this 24 times b is equal to 8 minus t squared. And if I want to find the distance, let's say this distance is d actually, and this d is the function of t. So what we write is the distance from the origin. So at the place of a and b, I'm going to substitute 0 and 0. So that's going to be 0 plus 0, and this will give you this side, so it will become t squared minus 8, and divided by the coefficients of a and b. So that is going to give us 64t squared and plus 24 squared. Now our entire situation is shifted on d actually. So let's simplify this first. So t squared minus 8 and divided by 64 t squared plus 24 square with the square root. Now the t is basically lying from minus 4 to 4, which mod 2 is lying from is greater than 4. So can we just see that at what point this dt will become minimum? Because when dt will be minimum, of course the reciprocal, this root of a square plus b square minimum, and then from there the reciprocal of that will be maximum. So at what point this t will be minimum? To find out the minimum value, what we can see, that here I'm just taking the t squared is greater than 4. It means I can now suggest the t square as a new variable, let's say u. It means now the distance, let's say this is now a new function, that's a d of u, is going to be u minus 8 divided by root over 64 u plus 24 square. Now if I simply differentiate this function, I'm just taking, okay, just assume that I've taken only this part and I want to find the behavior of this du. So let's find the derivative there. So d dash of u, and that is going to be 64 u plus 24 squared, and here I have the root of this. I have to keep this thing, by the way, 64 u plus 24 squared into derivative of u is 1, and minus u minus t, u minus 8 rather, and 1 by square root of 64 u plus 24 square and into 64, and there is a 2 also, 1 by 2 root this, and then so this will become 32, and this will go up here, so it will become 64 plus 24 u 64 u rather, is a u by the way, 64 u square minus 32 u and plus 32 times 8. Now in denominator I will get this 64 u plus 24 square to the power 3 by 2. This kind of differentiation we have done many times. My intention is to show that is going to be positive only. You notice that 64 u minus 32 u will become 32 u, and this is 576 and plus 32 into 8. So it doesn't matter what you have substituted the value of u, but u has the value, minimum value 16 actually. If you're just assuming this t square, okay, this will be 16. So u is getting the minimum value 16. It means the function is decreasing. So this value will become minimum when we take the minimum value of the u. It means I'm going to substitute u as equal to 16 there. So our dt will become, the distance d will become minimum at, let me write, d min is going to be d of 16. Let me write in this way. So I'll give you 8 on the top, and denominator I have 64 into u, 64 into 16 rather, and plus here I have 24 into 24. You notice clearly there's a square root, by the way. What you notice there is from each of the term I can take 8 common and 8 will get cancelled. So I'm getting here as 64 out, so of course let me write it, 8 is out, and therefore it will give me 16, and from each of these two terms I will take 8 and 8, so that will remain 3 and 3, so 9, and this was 8 already, so this is going to be 1 by 5. So d min is 1 by 5, therefore the maximum value of 1 by square root of a square plus b square is 5. So in this way we get 5. There is one thing when I was solving this question, I also realized that this can be done in a different way. So let me just take this thing and show you how we can do without understanding this line thing. So in this method, what I did, that I've taken this line there, I tried to understand that this is a line actually is here, and since root of a square plus b square is the distance from the origin, so we are finding the distance of the point a comma b, which is lying on this line geometrically in the plane of AB, and that distance will be minimum when we find the perpendicular distance from the origin to the line. But can we do a little bit different or better? Maybe this geometrical aspect will not be seen in a very first quick moment, but we can see different thing. What we can do, this was the setup we have already. From there, what we can think better. So what I'm thinking, let's see this 8at I'm writing as it is, and 24b I'm writing as it is on the left hand side, and sending this 8 minus t square on the right, miss that, and I'm dividing the entire equation by 8. So what we get it here, at and plus 3b is equal to 1 minus t square by 8. Now you remember this is actually inviting, because what we have to find actually is think this way, that this is a, it corresponds to a square, means I need this a square, and this is b, that is a b square. So you notice that how we can relate the a square plus b square from there is actually there. Let's see. There's identity, or maybe the inequality, Cauchy squares inequality. So from the Cauchy squares inequality, the statement is very simple. Suppose I have this a and b are the two distinct elements. So a square plus b square I've taken here into the product with their individual product with t and 3. So I can write t square plus 3 square, and that quantity must be greater than equal to the at plus 3b the whole square. So in this way what I can write is the a square plus b square is greater than equal to at plus 3b the whole square divided by t square plus 9. Now you notice one thing, that I have to find out the minimum value of this quantity, and already I have the at plus 3b value given. There's 1 minus t square by 8. So let's substitute it. So this I'm substituting, and I'm calling this equal to that. So this is going to be what? 1 minus t square by 8 the whole square divided by t square plus 9. Since I have to find the square root minimum value, so I can take the square root both sides. So a square plus b square square root is what? 1 minus t square, sorry, 8 minus t square, and divided by 8 times okay, this is gone actually, and what do you get? Okay, that's correct. And here we get root of t square plus 9. Now the same story repeats there. It's a similar kind of thing we got there. If you understand it, they're the same thing. From there we got almost there only, because here the 64, we take the 64 out, we get the same scenario, if you can understand this thing. So from there again we have to do the same kind of calculation drama, and we get it. This minimum value is happening at, because now I have to find out the minimum value of this quantity, and since this quantity is again in terms of t, which is already conditioned with the value of t, so this can possess the minimum value at some different value of t. So I am actually trying to find out the extreme minimum of this root of a square plus b square, because it is greater than this, so it should be greater than the minimum of this quantity actually. So I want to find the extreme minimum of this, so I have to first find the minimum value of this quantity. So let's assume this again dt, and again the same thing will happen, 8, and because I'm taking the mod this thing, the root there, I have to assume there is a mod actually, and now it will not be affected by the minus or plus sign, and again it will happen at d. Min is nothing but d5, d4 actually there. So d4 will be again 5 actually, because here you substitute 4, so 8, that's it, so 1 by 5. In that way again it will come as the maximum value 5. So this was the solution what I thought for this question, and I presented to you. So that's all for today. See you in the next video with some other interesting question. Stay math active.